In this video, we are going to prove that sine of a plus b equals sine of a times cosine b plus cosine a times sine b. So let's start by having this picture of two angles. This would be angle A and this would be angle B. And then I'm going to construct from this point down a right angle. So that's a perpendicular line. Let's call this triangle AOB. Then from B, let's construct a perpendicular to this side, which we call this point C. And from C, we go with a perpendicular line to this segment, and we call it D. So now, let's start with sine of A plus B. So we are in the right triangle AOB or OAB, and we want to find sine of A plus B. Now, we are talking about this triangle. So sine of A plus B is the opposite side, which is AB, over the hypotenuse, which is OB. Now let's use the fact that AB, the segment AB, is made by these two segments, which I'm going to draw this perpendicular side and call it CE. So let's say that AB is BE plus EA over OB. Now let's separate it into BE over OB plus EA over OB. So we have BE over OB, and they are sides in different triangles. So I'm going to rewrite OB as BE over BC, so that I make sure that now when we say BE over BC, now they are sides in a right triangle, times BC over OB. So now I hope you can see that by introducing this to the numerator and denominator, they can cancel each other, and this is the same with the original fraction, plus EA, well, instead of EA, instead of this side, EA, I'm going to write CD, because EA and CD are equal to each other, over OC. And why choose OC? Because I want to have now sides in triangle ODC, times OC over the original OB. So again, I hope you see how OC and OC from here, that's O, can cancel out, and it's the same thing as it was originally, because CD, it's the same distance with EA. So now we can start replacing. When we go to BE over BC, so BE over BC, well, there are opposite side or adjacent side, but we have to figure out of what angle. Now, looking at the right triangle, that, let me call this F. Looking at the right triangle OAF, this side or this angle would be 90 degrees minus A. This one it's opposite, so it would be 90 minus A as well. So this angle here is gonna equal A degrees. So the same, because this one is 90 degrees and this angle is 90 minus A, this angle will be A as well. So now, looking at the blue triangle, this one, the side BE over BC means cosine of A. So let's write cosine of A times. Now let's look at the second fraction, BC over OB. BC over OB means that we have to look at the green triangle now, because BC and OB are sides of the green triangle. So BC over OB, it's actually sine of B. Plus, let's look now at the CD over OC. CD over OC, that would mean that they are sides in the yellow triangle, CD and OC. So CD and OC, it's actually sine of A, opposite side and hypotenuse, times, and then OC over OB. OC and OB are sides in the triangle OCB. So that is, OC is the adjacent side and OB is the hypotenuse of angle B. So cosine B. So if I rearrange it and I write this term first, it's going to be sine A times cosine B plus cosine A times sine B. So it's exactly what we wanted to prove. Now looking at the same picture, let's try to prove the cosine A plus B. So cosine A plus B, we know that the formula is cosine A cosine B minus sine A sine B, but where are they coming from? So let's start with cosine A plus B, and looking at the picture to the right, to the left, we have in the right triangle OAB, cosine of A plus B is OA over OB. And looking the same and using the same procedure as before, instead of OA we put OD minus AD over OB. Now we separate into two and we kind of get the idea of the minus, right? We expected to see a minus. Now instead of OD over OB, we are going to put OD over OC times OC over OB. So where are they coming from? Well, instead of OD over OB, we use OD over OC because we want to have a right triangle. And we want to have legs and hypotenuse. And OD over OC, we are going to use the right triangle ODC. And we're going to see that OD over OC, it's actually cosine of A. And then minus, and instead of AD over OB, we are going to write EC over BC times BC over OB. Because it's clear that AD and EC are equal to each other. So now, OD over OC, OD over OC, it's cosine of A, times OC over OB is cosine of B in the triangle OCB, minus EC over BC is sine of A in the triangle CEB times, and BC over OB is sine of B in triangle OCB. And then we proved what we wanted to. But now that we proved the two identities, what about sine of A minus B? Well, we are going to write sine of A plus negative B, which is the same, right? And I'm going to use the formula above, which I highlighted in purple. And we're going to have sine A cosine negative B plus cosine A sine negative B. We know that cosine is an even function, so that means cosine of negative B it's cosine B, because cosine is even. And then we know that sine is an odd function, which means sine of negative B is negative sine of B. So that means minus cosine A sine B. And we proved sine of A minus B. But how about cosine A minus B? So I'm going to use the same procedure, cosine A plus negative B